Promaster conversion part 18, installing the electrical. So as you can see, my electrical box is at the top towards the front of the van, and this is my electrical box. I'm going to take off the cover here so you can see my battery bank and how I wired it up. So install of electrical. Basically I put it here at the front part of the van, as you can see, and the reason is because I've installed these before, just like other vans are installed in the back. Usually a very difficult place because it's hard to install it, it's hard to check it, inspect it, and all the other work if you want to add something, subtract something from the electrical system. So I wanted to put it in a place which I had easy access, it'd be easy to work on and inspect it. And especially being in an automobile, you're going to need to inspect these, you know, pull on the wires and stuff, make sure they're not loose or anything like that. At least once a month you need to make sure all your battery connections are tight and everything such as that. These are 3 lithium batteries. They're 100 amp batteries. If you're wondering about the wiring, I highly recommend you use crimp connectors with shrink wrap. This is double-aught wire. Very little loss of electrical power, very efficient. And like I said, if you do these, use crimp type fittings is the best. I've used the screw-on ones before and they just get loose, but these are definitely highly recommended. Now, in a lot of these electrical systems, you'll see a plug-and-play system where you see all the buses and connectors, fuses, they're all combined in one, but the price of these is just outrageous, anywhere from $2,000 to $3,000. All this takes is a little more time. Components are just as good. I highly recommend you do it yourself if you're comfortable with doing it, and you'll save a lot of money. It may take a little more time, but you're going to save the money tenfold. So and obviously calculate your wiring size. You can see right here you have a fuse and you have your shutoff. I highly recommend getting one of these marine shutoffs. It makes it very easy to work on, very safe to work on. Put it in its off position, you won't have any problem with grounding anything out. Now, one thing I will say, there is a little controversy. Do you put the shutoff on the positive side or do you put it on the negative side? You know, the reason they put it on the positive side is because boats are basically plastic or fiberglass, so you don't have a problem with grounding out. I went ahead and went with the manufacturer's instructions. They say put it on the positive side, so I put it on the positive side. But obviously on a vehicle you have a lot of metal, so it probably would be more advantageous to put it on the negative side, but it really doesn't make any difference. So do whatever you feel is comfortable. Now as you go through this, I have the cutoff. Then obviously you have the positive bus. They have caps that go over this so nothing can fall over or anything like that and short it out. They have caps, black caps obviously for the negative, red caps for the positive. And like I said, it's very easy to access. I highly recommend you put your electrical components where it's easy to access. As far as the inverter, this is a 5,000 watt inverter, and it can be hardwired into 120 volt plugs. This is a very large inverter. 5,000 watt is more than most people will put in their rigs, but I put it in. I got a pretty good deal on it, plus I use equipment that has a high peak wattage startup. That's why I decided to go ahead and put this 5,000 watt inverter. This also, I got this because it has a remote switch. It also can be hardwired, as you can see right here, and I'll show you how I hardwired that. And yeah, and it's a pure sine. You could probably get away with a modified sine around probably 1,500, 2,000 modified, which would be the cheapest, and you could probably get away with something like that. But depending upon what you're running. Some microwaves, you're going to need to do a pure sine, or you're going to keep popping the fuse on them. Now I'm going to show you my power supply center. This is the main battery bank, and then the power supply center is up here. Now this is your I decided to go with a power supply center like this, and here's my control panel right here, nice and clean with the illuminated switches. And as far as the supply panel goes, the reason I went with this is because it's all in one kind of thing. You have your DC fuses here, and if one blows, there's an indicator light that tells you which fuse is blown. As you can see, it's very easy. I don't have any obstruction. I can see if I got any problems, recheck the wiring, pull on the wiring, make sure it's nice and tight. As far as the 120 breakers are up here, very easy to access, very easy to inspect. And as you can see here now, if you see here, you see a red wire, which is usually power, but I have it phased to green if you see the green tape. This converter, hardwired, is just like a regular electrical in your house. You have a black, which is hot, a green, which is ground, and then you have a white, which is common. So if you're going to wire this up, obviously even a Home Depot or whatever type of electrical box is pretty much wired the same. The only thing when you do this, you need to bound, what they call bounding the box to the chassis. The box itself isn't grounded, so you have to ground that. So you need a dedicated ground over here. You run it through the back, it'll usually say bonding hole, and you go through that and you ground to the chassis. Now back to the inverter. You've got your white, which goes to your white bar, your common. Then you have your ground, which is a red wire, but I phased it to green. This is your ground bus for your AC. And then your black all go to your fuses. And these fuses, depending upon what you have, are just regular like house fuses. They pop right out. And if you look over here, all these grounds are your DC grounds that go with your panel here. Now this particular power box also has a converter in it, which will charge your battery bank. You need to make sure your converter is putting out enough power, depending upon what type of batteries you have, lithium, gel, lead acid. Make sure it's putting out enough power to make sure you get a full charge on your battery bank. That'd be one tip that I would suggest that you use. Like I said, I got this box because it's easy to work on. Now, as far as the switches go, if you look here, you can see my switch panel here. You got a Victron battery indicator, and you have the switches, which are these marine switches, and of course you have your solar up here. Now, a little tip on these marine switches. Now, I highly recommend you get the ones that illuminate. So when you turn the switch on, this illuminates. So, but you don't want it constantly illuminated, because if you've ever had these before, the bottom part will be illuminated, and it is very distracting at night when you're trying to sleep. They're just too bright. These LEDs are just too bright. So it's easy to fix these. So a little tip for you: when you get these panels, they're pre-wired. You have a red, a black, and a blue and a yellow. And over here, each one of these are powered separately, and then they power like two switches each one of these. So you just wire your red and you wire it to your bus. And if to only have these switches illuminate when you turn them on, all you have to do is on the yellow wire, which is always usually connected to your black, you cut that, wire nut it, tuck it back in here, and on your red wire, you have a blue. And what you do is you just cut the blue wire, and then you wire nut it, tuck it back in there, and you can, and that'll turn off the switches unless they're turned on. And then once they're turned on, now why would you want the switch? Some people say, well, I don't need switches that illuminate. Well, you kind of do, especially in rigs that are heavily dependent upon battery power, and you have to always be conscious and monitor your battery power. The reason is let's say you leave your converter on. Like here's my switch for the converter. If this is on and illuminated, I know this inverter's on. There's been times where I've had switches that weren't illuminated and I left the converter on. Well, the converter will drown your battery. It'll kill your battery after time. So you want to make sure you only, for your converter, for example, you want to be able to look over the switch at a glance to see that it's on, and then remind you to turn it off. So that's why you want switches that are illuminated, whether it's your water pump or anything like that. If you ever got a leak, your water pump's running, you burn out your water pump, run your batteries down at the same time. So that's pretty much the electrical, and that's the system. So just to give you a look at it from a distance, this is how it kind of looks down here, and you have your cover that goes over. The sink will go here, and so that's pretty much how the system is set up. I hope this helped out anybody that's doing any wiring. If you have any questions, please feel free to email me, subscribe, and give me a thumbs up. Thanks a lot. Have a good day. Stay safe. Bye-bye.